Welcome to EcoVapor's MobileZero product launch webinar. We have a all-star panel with us today from the company: CEO Jason Rowe, COO Hans Mueller, Jeff Wilson, Strategic Marketing Manager, and Ian Johanches, Project Engineer, are with us this morning. Jason, I'll hand it over to you.
All right, thank you, James. Good morning to everybody. Good afternoon or evening if you're joining us from across the pond. I'd like to start by just thanking everybody. We know how busy you are, and we appreciate you spending a little bit of time with us today. I'm Jason Rowe. I'm the President and CEO of EcoVapor, and I just want to spend a few minutes with you before we dive into the real topic du jour, which is the launch of our MobileZero product line. So, as we all know, our industry is under a lot of pressure. We know how important access to affordable and reliable energy is, and it's never been more transparent in our world than it is today. And as we continue to meet these challenges as an industry, I think we all recognize that there's still improvements that we can make in our operations, and we're facing a lot of rising pressure to manage our emissions, and as our social license to operate continues to be challenged. And just a handful of examples, as you can see here, you see a lot of great initiatives coming out on the elimination of routine flaring, increasing gas capture. Gas capture and flaring is a huge source of emissions in our industry, and glad to see that we're taking the steps that we are. But another one that I'd highlight, and we know that access to capital, our cost of capital, continues to be affected and continues to increase. And so the one area that I would focus to here is this greater transparency. As you know, we've largely as an industry been calculating our emissions for quite a while. And as we continue to get better and start monitoring and start looking at more where the true sources of the emissions are, this greater transparency is only going to lead to greater action as we continue to learn more and more about where the problem lies. And so, we as EcoVapor, of course, are excited that we play a role here. And so to take this one step further, we wanted to just take a couple minutes here to dive a little bit deeper into some data on the key sources of emissions. As an industry to date, we've largely focused on monitoring LDAR. There's been some focus on items like pneumatic devices, flaring. But I think we need to dig in a little bit more to this data to see where we can really take meaningful action. And so what you're seeing here is some data that comes from the EPA, based on submissions from operators. And just to give you a sense of where we are seeing some of these sources of greenhouse gases in our operations. And as you can see here, in this is 2019, 2017 data on flaring and as well on emissions reporting. You can see things like pneumatic devices, associated gas flaring, tank flaring. And if you look at the flaring, it's all from associated gas and the storage tanks. And so you can see here that truly as an industry, if we want to take action and if we want to make sure that we can meet our net zero objectives from the ESG perspective, we have to take action on tanks. But then, but I think it's also important that we take a step back from this data. And so if you look at, okay, well, how accurate is the data that we are actually reporting as an industry? As a lot of you know, a lot of the math that we're doing, a lot of the data that we are providing is largely based upon calculations based on equipment and some assumptions that can be taken. And we do have, the LDAR campaigns that are out there that also aid in some of these calculations. And, I mean, an example, we largely assume 98% combustion efficiency from the flare. And so, and we all know that, that sometimes can be accurate and sometimes cannot. So as we look at, and recently you also saw that the IEA came out with some data talking about, well, there's a chance that, we're 70% underreported on our emissions footprint. And so we highlight all this just to say that, look, we know that tanks are a significant source of emissions, but we also have to look at how accurate really is that data. So then as we transition into some actual data, we can call up an actual case study that came out of the Permian Basin recently. In late 2020, an Upton County operator said, well, hold on, let's make sure we truly understand our emissions footprint. And so they embarked on a program where they said, let's do fixed wing drones, truck mounted, ground continuous monitoring devices over all of our operations and get a sense of where our real emissions footprint comes from. And now if you rewind to where we were on the previous slide, you remember some of those figures, but then let's take a look at this chart on the top right. And it's interesting to see when we compare the actual versus the projected where we're lying. And so, and clearly here what they're seeing is that tanks were the majority of their emissions footprint, equating for 68% of the emissions coming from their sites. You can see 12% based upon the factors that were provided. Pneumatics and fugitives, on the reporting equated for about 83% of the emissions, and you can see on here that based on this study, quite a different representation. And so, it's compelling information. I think it causes us to take a step back. And there's also been some recent data that came out from the EDF based on surveys from 2020, 2021, based upon a lot of the flyovers and ground monitoring, continuous monitoring that were done in the Permian Basin. And similarly, they found that 79% of the emissions coming from the production process, which, as we know, the production process is, probably makes up around 80% of the emissions footprint of our E&P industry. And so if you're talking about 79% of that coming from tanks, whether it be feed hatches, venting, flaring, et cetera, that is a significant chunk of our emissions footprint. And so we look at this and we think that, well, our industry is compelled to take action, but let's make sure we're taking action where we can take sizable action and take a meaningful bite out of this pie. And so that's where we sit here and say, okay, well, let's make sure that we're looking at this from that perspective. And we believe that you cannot meet these ESG targets. You cannot meet these net zero targets without addressing tanks and without addressing tank flaring. And so, we believe this is compelling. And I think one added opportunity here that we like to highlight a lot is that this is typically your richest gas on site. It's compelling, and this doesn't just need to be an emissions conversation. This can also be an ROI conversation. And so it's a compelling opportunity to dig in. And I know that a lot of operators like to measure how they go about their initiatives on the emissions front by what are my dollars spent per CO2e abated? And that's exactly what we're here to provide. That's exactly the storyline of EcoVapor. With that, this is exactly where EcoVapor, we focus our attention. We provide solutions to eliminate natural gas flaring and venting. And as you can see here, our goal is very simple. Sell more, waste less. We know how scarce of a resource we have, and we know how hard our industry works to produce it. And so if we can if we can put more of this natural gas into the pipeline and less into the environment, then we're doing a great thing. And I think that that's what we're here to enable. And so if you look at this, really what we're about is maximizing gas capture and sales on a production site. We focus on oil and gas, which we'll talk about here a lot, but we also have recently been focused a lot on the renewable natural gas solutions as well. Our core competency around gas purification so that it's enabled to be pipeline ready equates well to the renewable natural gas industry as well. And on the oil and gas side, which is where we're going to spend the majority of our time today, once again, focused on the core areas where we have true expertise around oxygen removal, H2S removal, enabling pipeline ready gas. We have a suite of solutions that help all the way from tank battery vapor management solutions, eliminating venting with proper tank pressure controls. We've also recently launched our Emission Scout, which can help to monitor and understand flaring volumes, gas contamination in those flared volumes. So a variety of solutions, but look, what we're here today to talk about is around mobile capture and treating solutions. There's a lot of operations today that we are continuing to waste gas or potentially flare gas or vent gas. And so we believe that a mobile solution can play a great role there. And so with that, I'd like to hand over to our founder and our COO, Hans Mueller.
Thanks, Jason. Hi, everybody. I'm Hans. Thanks for being with us today. Let's take a look at EcoVapor's latest product, the MobileZero, where it fits and what needs it addresses. I think that we all know that there are many causes associated with regular operations at a well site that necessitate flaring or combustion of natural gas. And some of those examples extend beyond the traditional production processes that EcoVapor has helped operators optimize for over a decade, like tank vapor recovery. But about a year ago, EcoVapor was approached by a few major oil and gas producers for help with flaring avoidance in temporary applications. There's a long list of them, and some of them include flowback, facility maintenance, including equipment cleanouts, like tank cleanouts, separator swaps, even facility startups. There's applications at pig receiver stations, gas well liquid unloading operations, jet pump installs, workover rigs, even when gas lift contamination, in an upset condition, will pop its head up, and then also very low pressure reservoir systems as well. And what those requests resulted in was this mobile product that can address these applications that we just discussed, and probably some that we haven't even thought of yet. The purpose of the MobileZero is to address exactly that, and that's to be able to purify gas and vapor to meet sales specifications that are set by the pipeline, so that in a wider range of applications, gas that would normally be destined to go to the flare can be sold. We've built upon our 12 years of experience, and what you're looking at is the MobileZero with its robust design that ensures that it's able to handle varying flow rates and concentrations of contaminants. We know that this is going to meet a lot of different locations, and I think we all know that every location is different. But because of that, gas treating is accomplished using a H2S scavenger that's solid, as well as a catalytic reactor. There's no liquid chemical handling or disposal required. All on-skid components meet Class 1 Division 2 requirements for hazardous locations. And also, the design is customizable to fit the applications and operator requirements that might be specific to your needs. Regardless of any customization, all MobileZeros are designed for fast mobilization and demob. There's just 4 piping connections and 480 volt power connection, just one of those that is required. We'll talk more about that in a few slides coming up. And everything is automated as well, down to the liquid dumps, all controlled by a PLC. The 3 vessels that are included on the MobileZero each play a role in ensuring that your gas meets pipeline sales spec in order to be sold and not flared. First in line is the liquid scrubber. Its job is to remove free liquids and drain from the gas stream. The 2 processes downstream are highly reliable, not highly sensitive, highly reliable and designed for wet gas service, but they don't like free liquids. So knocking out any liquid slugs is important. That's why that scrubber is there. The Sulfur Sentinel is the vessel right in the middle, and that's an inherently reliable way that self-adjusts to varying concentrations of sulfur at the inlet. And last but not least in the process, the 02, that takes care of any and all oxygen that has made its way into the gas stream. And by removing that, we ensure that you do meet that sales specification that's set by the pipeline. There are no moving parts on this 2-axle trailer. That ensures reliability and significantly reduces maintenance requirements. Its height of 13 feet means that it can go anywhere in the lower 48 and fit onto your location with no DOT restrictions. It's easy to hook up. We'll talk more about that soon. And this particular model that we're looking at is designed for a flow rate of 150,000 cubic feet per day with a maximum operating pressure of 260 PSI. But it's easy for us, as we already have done it, we're able to design to meet flow rates of over 1 million cubic feet per day and have operating pressures in excess of 400 PSI. Last thing I wanted to mention on this slide is the remote power panel. That does mount to the trailer for transport, but should be set a distance away from the trailer to maintain that hazardous area classification. We'll talk more about this soon, but cables are already provided, and there's only one electrical hookup to make to the facility. Let's take a little bit of a closer look at some of the select components, what they do and why they're included in the MobileZero. First off, we already talked about the liquid scrubber, but just a little bit of a closer look. It's pretty standard. It's sized properly for the application. Both of the float switches are electronic, which means that there's no pneumatic valves, which eliminates the fugitive emissions associated with those. That lower float switch controls the liquid dump valve via the PLC, and the upper is a high level shutdown switch. What's not visible in this particular view is the sight glass. There's also a diverter internal to the vessel at the inlet nozzle, and also inside is a mist extractor pad. This particular model shows that it's rated for 260 psi, but again, we can build these to any spec, including ANSI Class 600. Sulfur Sentinel. What you're looking at on the right-hand side of the slide is an example of a standalone unit. Again, like the scrubber, this was built for a specific application, but it can be designed to meet your flow rate and operating pressure requirements. And its sole purpose is to remove H2S from the gas stream. That's important for the process immediately downstream, and also to meet sales spec. It is simple. This is a simple, low pain in the butt way to sweeten your gas that is flexible to the application. You might be sensing a theme here that there's no moving parts. And in terms of application fit, EcoVapor's rule of thumb is that it fits best into applications with 2,000 parts per million H2S or below, but that's all that is a rule of thumb. We've seen application fit up to 15,000 ppm before. So one thing to note is that the H2S removal reaction does create water. That is the reason for the liquids dump. We'll talk a little bit more about that later. But also you might encounter sites that we know for sure are sweet and that there's no H2S present. On the MobileZero, there is bypass piping included, so you can route the gas around the Sulfur Sentinel. But important to note that there is no harm in moving gas through that media. If there's no H2S entrained in the stream, it passes through the media unaffected. And also worth noting, like we're looking at right here, standalone units are available. And last but not least on the MobileZero's process is the 02. Its sole purpose is to remove any air contamination in the gas stream so that we can sell it, not flare it. This large catalytic converter designed for the oil field is able to handle high flow rates and high pressure. And also all the onboard automation automatically adapts to operating conditions like varying flow rates, varying levels of contamination. And it also continuously samples the outlet stream to ensure the salability of gas, and it adjusts accordingly if it does not, by diverting that gas to the flare line for a temporary period. And taking a little closer look at the 02's technical specs, for those that are not familiar with the 02, here are some of the specs that we have for our E300 skid. That's good for 300 MCF a day. In terms of pressure, static rating can get up to 410 psi, but the differential pressure is also interesting. This is something that we try to tailor to the application to make sure that it is well within range. We can get that down to about 2 psi. Maximum is about 10 psi, and that's really where differential pressure is not an issue. But if you do run up against a constraint, it's easy for us to adapt and reduce that. The flow does, the differential pressure does depend on flow rates, operating pressures, and gas composition as well. So we've got a really good sense of what that differential pressure is going to look like before we even deploy, and can make any adjustments that your application requires. These are good for purifying significant amount of oxygen. Continuously, we can handle up to about 35,000 parts per million. That's 3.5%. But on an instantaneous basis, can handle up to 50,000 parts per million. that equates to about 25% of the overall stream being air and gives you a 5,000x safety factor to be able to sell gas that you normally wouldn't be. One other thing I do want to highlight is power draw. This unit does require power. We've got our maximum power draw listed up there during startup conditions at 45 kilowatts. That's typically used for about first 30, maybe up to 60 minutes of startup time, but it tapers dramatically once the unit gets up to temperature. And also, if your application requires, we can cap that maximum power draw down to 30 kilowatts or below in some circumstances. I think at this point, I'd like to turn it over to EcoVapor's project engineer, Ian Johanchis, to discuss operation of the unit and hookup.
Thank you, Hans. Appreciate that. So today we'll be talking about the operation of the MobileZero. I'd like to highlight three key categories here. We'll go into the mechanical side, the electrical, as well as the automation. And then we'll show a few pictures of example hookups in the field. So there are 4 piping connections on the MobileZero, starting from the right and working our way to the left. Number 1, that is the inlet to the MobileZero. That'll come off the discharge of the compressor and flow straight into that liquid scrubber. Number 2, that is the liquids dump, and this is a combined line off of the liquid scrubber as well as the sulfur sentinel. Number 3, that is our divert line. This is connected to the flare, and go into a little more detail about that, but pretty much during startup periods when our reactor is below temperature, we're sending gas through that divert line and making sure it's not being sold until that O2 level comes down. And then number 4, that is our sales line. Now it is very important that number 3 and number 4 do not get confused, because we could be sending clean gas to the flare and vice versa, gas that has not been deoxygenated to the sales line. So here's an example hookup of how an operator has done it in the field. Again, those mechanical piping connections are 2-inch, 150-pound connections. What has typically been done is they pipe off to the edge of the trailer and then transition to flex hoses with a few unions. This makes it for simple hookup, and then demobilizing is pretty straightforward. So here I'd like to touch on the electrical. Again, the name of the game here is simplicity. There are a few connections we'll highlight. There are 2 panels. One is a 480 volt panel. The second is the 24 volt PLC automation panel. So with that 480 panel, that's mounted to the trailer itself. However, that will have to be removed and placed outside the hazardous classification area. And that panel does have 3 cables with it. One is the heater power that is pre-wired and stays attached to the panel, runs from the 480 volt panel to the heater on the 02 E300 unit. The second and third cables are for our 24 volt power and our 24 volt signals. Those cables are not interchangeable, so operators cannot hook those up backwards. And then the one thing I do want to stress here is the only thing that the operator will have to do out on site is run facility power to that 480 volt panel. That is it. I'll just touch on the power draw on that E300 unit. During startup, we're looking at about 53 amps. However, during normal operation, steady state flow, our heater backs down and typically only draws about 30% of that max amperage. And that's due to a gas-to-gas heat exchanger on the front end that preheats our inlet gas and cools the outgoing gas. here's a picture of a typical installation out in the field. Again, just want to highlight that the 480 volt panel is off the trailer and placed outside that hazardous location area. So what we're looking at here is the process flow diagram. In blue, that is our main process line. In green, we have the dump piping. And then the red is the O2 sampling systems. We have one on the inlet of the 02 as well as the outlet. But what we'll do here is we'll quickly highlight some of the automation that is included on the MobileZero. So starting from the left, the bottom left, we'll start with the two dump valves. There is one on the scrubber as well as the sulfur sentinel. The one on the scrubber is level-based control. When that low-level switch is engaged, that will operate. And then when the high-level switch is engaged, it too will open as well as close the inlet valve to our 300 or 02 to restrict any flow through the unit, as well as evacuate any liquids. So again, with that inlet valve, that is for emergency equipment protection. Again, closes when that high level switch is engaged. And then when O2 level concentrations are actually greater than what we can handle, above 50,000 parts, to put that in perspective, that would mean about a quarter of the gas stream is air. And at that point, we would advise probably need to look upstream to see if there's any valves or hatches open, letting air into the process. And then finally, to the bottom right, we have our divert valve. This is oxygen based, and it regulates where gas is off skid, to the sales line or to the flare. That is normally closed and then opens when our O2 levels exceed the max set concentrations, typically about 8 ppm, and then closes and sends gas to the sales line when our gas is in spec. And typically that is during cold startup periods when our reactor is below normal operating temperatures. We'll see the higher levels of oxygen. And then when we do start to heat up, that oxygen level comes down, divert valve closes, sends gas to the sales line. And the last item I would like to highlight here is we do have a back pressure regulator on skid. And what that allows it to do is keep everything upstream in steady state process. And it doesn't matter if that divert valve is open or closed and where gas is being sent. All right, I'll hand it back off to Hans to cover a little bit of the maintenance.
Thanks, Ian. So EcoVapor wants to meet your needs and support you in whatever way is desired. Some people like to maintain as much equipment as they can on their own, in which case we can provide training, no problem. And other people want to focus on putting oil in the tanks, and we can certainly help there too. EcoVapor is able to provide both preventative as well as call-out services, and particularly with the MobileZero, a lot of variables are introduced when visiting multiple locations, each with their own individual and unique characteristics. What I'm trying to say is that multiple temporary deployments can make maintenance less predictable than long-term standalone installations. So how do we do that? Well, there's really two things that require maintenance. That's the sulfur sentinel and 02. And the sulfur sentinel adsorbent media is an adsorbent. It does get used up in the reaction, so we need to monitor the bed health. And that needs to also be done while the unit is in service so that we can understand where H2S breakthrough is occurring, where that mass transfer zone currently exists. And it also allows us to predict the occurrence of those media changes. These are designed to be good for about a year. But again, there can be upset conditions, and that's why staying on top of that is your best bet. Also, on the 0.2 side, the oxygen is handled, in contrast to the sulfur sentinel, oxygen is handled by a genuine catalyst that is not used up in the reaction. It's precious metal in nature, which is great because we don't need to replace it. It just doesn't get used up. But calibration of that onboard oxygen analyzer is important, and especially when it's being transported from site to site, if the proper procedures aren't followed, that calibration for the O2 analyzer can be thrown off if it comes in contact with atmospheric air that has a oxygen content of 209,000 parts per million. So that can be important. There's also some preventative maintenance that we recommend on an annual basis, just making sure that everything's free flowing, that the flanges are torqued, the heat exchanger is not clogged by anything that it might have met on one of those sites that it was deployed at. But again, this is where EcoVapor can help. So we'd recommend setting up a service contract for preventative maintenance. So how can you work with EcoVapor? My favorite answer is to say however you'd like to. EcoVapor is flexible to whatever works best with your operating budget, whether that's a leasing model or direct purchase of equipment. Either way, service technicians are ready to support your operations no matter that commercial model. We are here for the long term, and we want to support your success any way we can. So to summarize, the MobileZero gives operators new abilities to rapidly deploy to applications where the needs are temporary for flare mitigation and emissions abatement. This product is built on EcoVapor's 12-year history of enabling the purification of contaminated gas streams so that they can meet the sales specification, so that they can go down the pipe and not in the air. And as always, whether we're in permanent installation territory or mobile temporary applications, EcoVapor's service teams are here to support you where you need and when you need.
Okay, guys, good job. We've got a few questions that came in from the audience. One is whether there was a model for an FPSO offshore, a floating production storage vessel, could be used offshore.
Is it okay if I take that one?
Go ahead on.
Not yet, but if there is a new application, EcoVapor's got a dozen years of experience where we try to meet new applications, that identify the needs, and build what it takes to address those. So I guess what I could summarize my answer to be is, challenge accepted. If you'd like to talk to EcoVapor more, please reach out to us. This is the type of thing that gets our engineering team revved up, and we would love to be able to meet your needs.
Yeah, thank you, Hans. And one item I would add there is that never hesitate to reach out on a variety of applications. We'd love to say that we were the geniuses that came up with the MobileZero, but the reality is it was designed to customer need. And with that, we learned more and more about there's a lot of these applications out there that simply can't be addressed by some of our existing products. And so here we are talking about it. So please reach out, provide your ideas, because generally the best innovation is coming from outside. So we welcome and we appreciate the feedback, and we'd love to talk to you more about any of these other applications.
Yeah, and I might mention to the gentleman who asked the question that we have talked internally in the past. We do have the 0.2 operating in saltwater disposal applications where we monitor the tank pressure and we guarantee an oxygen-free blanket, which I've often wondered if an oxygen-free blanket would not be something of a significant safety enhancement for an offshore vessel that was storing large amounts of crude. So perhaps there's a good discussion there. Second question, Was the max H2S 2000 ppm? I think, Hans, it's a factor of volume and concentration, but you might address that question.
Yeah, happy to. Really, it's a practical limit in nature, and the media itself can handle far higher concentrations. But why I say it's practical is the media does get used up in the reaction. It's an absorbent, not a true catalyst. So the frequency of those media swaps, just might become untenable. That said, we have certainly the ability to design the Sulfur Sentinel vessel to that application. We can increase the internal volume to make sure that the media changeout frequency meets your desires. But that's why I say it's only a rule of thumb. We've had up to 15,000 parts per million concentrations where it does fit that application. So really, it's something where I'd encourage you to reach out to EcoVapor and we can discuss your particular application on an individual basis.
And that's related to another question we have, Hans, on you'd mentioned we could go up to 1 million cubic feet a day and 400 psi. Is the range 150 to 1 million? Is that kind of the applicable range?
Yeah, I guess it's similar to my answer on the floating platform. Is give us a challenge. We can certainly meet it. We've got multiple locations. I think 6 of them now where we're treating over 2.5 million cubic feet per day. These are also stackable in parallel. That probably doesn't fit as well for a mobile application, but our largest 0.2 on a single unit basis can handle about 1.25 million cubic feet per day. So that's where I say that, but we've also, we've got more tricks up our sleeve. If we needed to treat 10 million cubic feet per day, I don't think that would be impossible, even on a mobile application.
Okay, we have another question again about H2S. The spec that the gentleman's interested in is if he has 500 ppm concentration and about 300 MCF a day, what's the media changeout frequency? So, Ian, you're going to have to do your calculation in your head very quickly. But I'm pretty sure it's several months.
Yeah. Oh yeah, I would say several months there. That's sounds like an application that would be sort of right in our wheelhouse there.
Yeah, that would be a great application. We can size that. One of the things we'll want to know is the pressure. One of the critical factors in treating the H2S is maintaining a velocity within a certain window to ensure that there's no channeling and to ensure that there's plenty of time for the reaction to occur in the vessel. So we could size that for you. Be glad to do that after the webinar.
Yeah.
And one item go ahead, Hans. One item I was going to add, guys, is that being this is a mobile application, obviously this can be changed offline. And, Ian or Hans, it might be worth commenting on the length of time a media swap actually takes.
Sure. Media swap operation typically takes a matter of hours. It's as simple as it sounds, where we, well, first off, it starts with the selection of the media. I'm sure most of us have heard stories where solid media is used to sweeten gas streams. But some of the operational challenges associated with it is that media can become very difficult to remove. And in fact, EcoVapor has put together a webinar that can be found on our website about this media specifically that EcoVapor uses and why. But I did want to offer that EcoVapor has predefined vessel sizes anywhere from 20-inch diameter up to 120-inch diameter, 10-foot, 20-foot, 30-foot shell lengths. So we can tailor it to that application, not only from a flow rate, operating pressure, and H2S concentration standpoint, but also to make sure that maintenance interval needs are met as well.
Okay, I have one final question here about mobilization and demob. Kind of asking, could you kind of summarize what are the major activities? And I mean, one of the questions was Does it require a roustabout crew? And basically, how complicated is it?
Sure. Ian, would you mind filling in any blanks I leave open? But I guess I'd say it's designed to be simple. Hopefully we've met our intentions there. But mobilization and demobilization both require 4 piping connections that are accomplished with a hose, trying to make that as easy as possible, as well as a single electrical connection for 480 volt power from the facility. I guess the last thing I'd say is don't forget to put down and also stand up the jack stands on the trailer. When you show up, you want to put those down. And if you try to drive off with the jack stands deployed, you probably won't get too far without realizing that you forgot something. Ian, is there anything else we want to consider for MOB and demob?
That's the major items right there.
Maybe make sure your tires are inflated.
Yes.
Grease the bearings and the wheels every now and then?
Yeah.
Yeah, there you go.
Okay, that's all the questions we have at the moment. Thank you.
Very good.
Awesome. All right. Well, from there, guys, I'd like to take a moment for everybody that's on the line, just to thank you once again for spending some time with us. As I'm sure you heard here, we're passionate about what we do. We believe that we have solutions that can help to economically achieve our emissions reduction goals. I hope you also heard that we're proud about the simplicity that we instill into what we do. We like to meet you where you are. We like to make sure that our products are easy to deploy. We'd love the opportunity to partner with you on some of these gas capture and gas purification opportunities that you may have. So, with that, I'll hand back over to James, but thank you once again. We look forward to working with you.
Absolutely. Hey, thanks, Jason. Thanks, team. Just wanted to let you know that the contact information, if you want to reach out to anyone at EcoVapor, there's contact information available in the slide deck of the PDF file. So thanks again. We appreciate your time and have a good rest of your day.